Today we're going to talk about congruent and similar. Okay, figures. And when I say figures, we may be talking about triangles. We may be talking about quadrilaterals, four-sided figures. We may even have something later on that has pentagons or hexagons, or we can have some funny-looking shapes. But they're going to be the same figures, okay? All right. So the first thing we need to talk about is what the word congruent means. And we've already talked about congruent at one point. And what does congruent mean? The same, okay? So if I tell you that I have congruent figures, what do I have? The same figure, okay? I'm going to have two of them. They're going to be exactly the same. You have the same angle measurements, same angles, and same side length. Let's just use measurement instead of length. I don't like that better. So same side measurements. The symbol that I use for congruent is an equal sign with a squiggly line on top. That tells me they're congruent. Okay? An equal sign with that little squiggly line on top. So sometimes what you'll see is, you'll see people, right, triangle ABC is this to triangle DEF. That tells me those two triangles are congruent, which tells you basically they're twins of each other. Okay? So they're exactly the same. They're like identical twins. Okay? I know twins sometimes can be different, but when I say congruent, they're going to be identical twins. You can't tell any difference in them except I've labeled them different. Like parents, they name their children different. Okay? Now, when we talk, also, we have the word similar. Okay? Similar means I have the same shape, but not necessarily, I spelled that wrong, sorry. Hold on. The same size. So one might be larger, okay, than the other one. Okay, so kind of twins, okay, that are not identical, okay. One might, when they start to grow up, one might start growing a little faster than the other, okay, or one might be born with some medical problems and that might be a little smaller than the other one, okay, but they still might look the same. Same thing with figures, okay. If they're similar, they're going to be the same shape, but they're going to be a little different size. So one might be a smaller size than the other one. Okay? The symbol for similar is just the squiggly line, not the equal underneath. Just a squiggly line. Yes. Okay. Yeah, it does make you think of the pie, except I just don't have the two little lines underneath. Something for... yeah, I would do the same thing. Then I would label, and I might have triangle RST is similar to triangle GHI. Okay, so I would still list the two shapes that I have and tell you that they're similar. Okay, and you guys will get into some of the similar stuff. I don't believe we do that this year. We may a little later, but at least next year you'll do some of the similar shapes. Okay, but we're doing congruent pretty much this year. Okay. Is everybody good? All right. Now I'm going to use my little tool up here and we're going to draw us a couple of triangles. I want to make him pretty wide. Try the best that you can. Okay? As big as you want it to be. It doesn't really matter. Do I now? Yes. Okay, I cloned him, so I know mine's exactly the same. So at this point, if you were to look at those, I have 3 triangles up there. Does everybody agree with that? Okay. 2 of them are congruent triangles. Which 2 do you think are congruent? ABC and then DEF. Which ones do you think are similar? Meaning it has the same shape, but maybe a different size. Okay, so A, B, and C and GHI are similar. And then also DEF and GHI are similar. Okay? Does everybody see that? How the difference between congruent and similar is? Okay. So it doesn't matter what shape you have. Do I have some funny shapes? Well, let's just do this. Okay? Okay, I may have that. Same shape, but different sizes, correct? Okay, what about, actually I'm going to go back to the page that we had over here. What if I have this, but I turn him? It's still the same. Is it still congruent? Yes. Okay, he looks different, so you might have a little trouble kind of looking at it. So if it's on paper, what you may want to do is look at one of them and turn it and see what you think. Does that look about the same? Okay. Now on SOL tests, you have to be really careful because if it's on paper or pencil, sometimes people will try and measure it and things like that. But on the screen, you're not supposed to touch the screen of the computer. I have no idea why. I guess they're afraid that somebody else is going to see you doing something to the screen and maybe cheating or something. I don't know what that is, but they ask us not to touch the screen. So if you have something like this, don't take a piece of paper and kind of draw that triangle that's on the screen with another piece of paper or use your fingers or anything. Can you use a ruler? It depends on if a ruler is available. They may not make the ruler available for you. They just want eyesight. Do you think those 2 things are congruent? Okay, so sometimes when they ask, they just want your perception of if it's right or not. Okay? Now, I'm going to actually, let's see. Okay. If they tell us that triangle ABC is congruent to triangle DEF, it doesn't matter if I can see those triangles or not right now. I know I have a triangle and it's labeled ABC. And I have another triangle and it's labeled DEF. Now, when we started labeling this one, we started with point A, correct? And then we read the second letter and then we read the third letter. When we start the second triangle, you're going to do the same thing. We start with a referral point, okay? So the first point I start on the second triangle is D, E, F. Now, things correspond with each other, which means if I have 2 shapes, I want to rotate him back for us so he looks exactly the same. Point A, okay, which is this angle. So when I do one letter, it's an angle. Angle A looks like what angle out of the second triangle? D. Does everybody see how those correspond? Now, sometimes they'll put little marks on the paper. Like I did one little mark here that told me that angle A and angle D correspond. Now, what angle corresponds with B? So I'm going to put 2 little marks here. So I'm going to go over here and put 2 little marks. Which which one corresponds with angle F? So I'm going to go over here and put 3. Do we see what I did? I'm kind of doing a little special mark. So if somebody looks at that, we've already said those angles are equal to each other. Got those special little marks. Now, you can do your sides the same way. AB, this side length, corresponds with what? DE, correct? All right. What about AC? It corresponds with DF. And what about CD? EF. Everybody see how we kind of measured that? Now, what you have to pay attention to is sometimes when they turn that triangle, okay, if they turn that triangle, I may need to draw it so they look the same. Okay? Because if I was to draw, let's look at one. Let's go in here and delete these two. So I'm going to draw 2 triangles, and I'm going to draw some right triangles this time. I don't know why he doesn't draw very well, but
Stage call up for checkout, please.
I slid him down so he. Alright. So now if I label this one ABC and this one RST, okay, you see how they made them turn different? It's kind of like your hands, okay? They're the same thing, but for me to be the same, I have to flip one of them, right? Or, in this case, I might have to rotate something, okay? They do that a lot of times with rectangles. They might have one laying down like this, and then they might have one sitting up like this, okay? So my first thing that I would probably do is I would redraw it so I know what corresponds with what. Even though right now we know that A corresponds with what? R, and B probably corresponds with S, and C corresponds with, okay? But when you're starting to refer things in a minute, you might accidentally go, well, A and T correspond. Well, they don't, okay? But as a quick reference, I look, well, they're in the same position. They're both to the bottom left of the figure, but they're not the same. A and R is correct. So that's why I say sometimes it's best to redraw it, okay? And we'll do one of those in a minute where you'll get some practice on that one, okay? All right. Now, if I said we have triangle ABC, and I'm just going to freehand this one really quickly, and we're going to say that this was 55 degrees. We're going to say this is 65 degrees. So that makes me, what, have 120? And so we're going to say that's 60 degrees. Okay, and then I'm going to have triangle DEF, and I'm going to say this side is 12, that side might be 8, and this side might be 10. Okay, I'm just kind of guessing that's the sides there. Okay, they're going to start to ask you reference. What side, let's do angles first. What angle corresponds with A from this triangle? D. What corresponds with B? And what corresponds with E? Everybody see what I did? Now, do you know what measurement angle D is then? I know they're congruent. So therefore, because I know that angle D and angle A are congruent, they're the same measurement. So do I know what A is? What? It's 55. So what is D? 55 as well. Do I know what F is? Yes, because I know what B is. What is B? So therefore F is. And what is E? See how then, because I know that my triangles are congruent, I can use information from one triangle to help answer questions in another one. See how I did that? Then you can do the same using sides. What side is congruent to AB? What side is congruent to EF? CB. What side is congruent to FE? BC. Because I started with F, I have to start with B. Does everybody see the difference? Okay. And then what side measures with AC? DE. Now, do I know what BC is? What the length is? Yes. I know it's 12 because of the EF. Do I know what DF is? What? And do I know what AC is? What? Did everybody see then how I use pieces? Okay, to help me solve those questions. Did everybody see that? All right, I want to pause this just for a minute. We got a worksheet we're going to do. All right, so let's talk about these. Number one, is that congruent? No. Okay, and I'm not going to be able to write on this, I don't think. We'll see. So no. Number two, is that congruent? Yes. Number three? No. Four? Yes. Looks like they flipped one. Five? Yes. Six? No. Seven? And eight? Yes. Now, it looks like they flipped it though, but it does, this one looks a little skinnier. But if you would take your paper and when you flip it, it kind of does look like skinny. I mean, so sometimes perception is a little different, so that's why sometimes it's easier to flip it, just to see once you flip it. Okay? Flip it. Okay? All right, now look at 9. Side AB corresponds to which side on EFGH? So I want to know what side here corresponds to AB. EF. So you would put EF right here. Now, if I wanted to write it that way, I would put AB is congruent to EF. And that's fine. Okay? Yeah. EF is fine. Okay? Side AC corresponds to which side on EFGH? EG. Angle B corresponds to which angle on EFGH? Now, number 12 says, what is the measurement of side FH?
6.
How do you know 6? Okay, so EF corresponds with BD, correct? Okay, so I'm going to put BD here because I know it corresponds. And when I look at BD, what's that side measurement? So therefore, what's this side measurement? 6. What is the measurement of angle G?
30.
Because it corresponds with angle C, which is 30. So angle G is 30. Yes. Yeah, you would really put 6 here. I just labeled him on my graph over here. So yes. Now 14 says calculate the perimeter of EFGH. How do you know what the perimeter is? What do you do?
Realize that 6 goes down, 6 is on the other side.
Okay.
12 is at the bottom side, and 12, and add that.
That's correct. I would add all sides together. Okay? Or I could have done my formula 2 times the sum of 12 plus 6, which would have still given me 36. Okay? All right, number 1. Similar, congruent, or neither? Similar. This one looks to be a little bit bigger than that one. What about this one? Similar. 3. Congruent. 4. 5. Similar. 6, 7, 8. Neither, because this looks like a square, and then this made me think of a rectangle. Okay. This one, 9, congruent. 10, similar. I'm going to hope that I can slide down over here on the side.
I'll try it. And why is it saying sorry?
Okay, you won't let me slide down. 11, neither. 12, 13, 14, 15, neither. 16, neither. Okay? 15 did kind of trick you a little bit. That's not the right paper you got. It's not on the board, but it's on your paper. They tell me that I have a quadrilateral ABCD, and he is congruent to quadrilateral RSTU. And over to the side, they showed you the corresponding angles and sides. So just kind of look at it. Yeah, this one we kind of did in our notes, but we did a triangle. They did a quadrilateral. So does anybody have trouble seeing that one? Now, the figure, if you look at the figure, they're not exactly the same. They kind of have rotated it. So when they rotate it back, A is congruent to R. Yes, it's the bottom of page 1. Okay? Not the one on the board, the one on the bottom of page 1. All right? But I'm looking at my given ABCD is congruent to RSTU, and that's how I'm matching up. Okay? Now, let's look at the one that we've got on the board. They use tick marks. And these triangles are not laying in the same direction with each other, correct? So, let's look here. X, Y, Z is congruent to what? So, let's look at X. And X, over here, lies between the 2 tick mark line and a 3 tick mark line. So which one of these points lie between a 2 and a 3 tick mark line? R does. Do you agree? Because 2 and 3, right? So X corresponds with R. Y corresponds between 1 and 2. So what point over here corresponds between 1 and 2? S. So S, sorry. Do what? Well, this one, if you remember from our drawing a minute ago, they put 3 tick marks to tell us that this side is the same as this side. And when they use 2 tick marks, then 2 and 2 match up. Okay? So most of the time they tell us measurements, though. Okay? But sometimes they'll put these little tick marks on there. And what other side matches with Z? T. So now I know that these 2 triangles. Now, according to this, angle Z matches up with what? Angle T. Angle R matches up with X. Line segment or side YZ corresponds with YZ corresponds with ST. And TS corresponds with VY. Okay? Alright, I want you to do the bottom one. Now, the bottom one, once you do it, also want you to tell me then if you know the measurement. Like we did in our triangle. So let's start with that one. Let's jump ahead. So this is the one you're looking at. And it says JN corresponds with what? If I look up here, what does JN correspond with? AE. Do I know either one of those measurements? Do I know the side JN? No, I don't know how long JN is. But I do know that AE is 18, so that is 18 feet. You don't have to put 10 marks. Okay? And I want you to finish filling that out. Okay? So I'm going to pause this for a minute. Alright, CD corresponds with what side? LM. And again, CD, see where he falls? He's the third and fourth letter, so this is the third and fourth letter, so that's LM. Now, do I know either one of those sides? Do I either know CD or LM? I know LM is 11.5, so both of those are 11.5 feet. DE, which is the last two, matches up with MN. But you understand, right? You understand using that guide up there? If they give you the guide, it's so much easier. But it's okay if they don't. Alright, so DE and MN, do you know the measurement of either one of those sides? I know DE is what? 4 foot. No. 120 is my degrees on the inside. So remember, that means inside, it's your degree, your angle. KL, which is the second and third letter, match up with BC, and that is 12 feet. Now, the measure of angle N corresponds to what? E, which is 120. A measures up to J, and that angle is 60.
Destiny White to the office, please.
C corresponds with angle, and it is 98. K corresponds with, and that is equal to, did you say 125? Yes, okay. Any questions? Okay. So let's look at this. It says, which angle corresponds to angle L? D. What angle corresponds to M? What angle corresponds to S? What side corresponds to LM? What side corresponds to MS? What side corresponds to SL? Anybody have trouble with that? DF, because, no, S come first, right? Okay, do you understand why M corresponds with C? They're the same measurement, 43, 43. So that tells me they're the same. Okay, so remember they have to have the same angle measurement. Okay? Alright. This one, some of you wanted to get stumped because it wasn't worded the way we've seen it. It says, what is the ratio of side LM length to the length of its corresponding side? The key word there is ratio, which tells me I want a fraction. Yes, ratio is always as a fraction. And I'm going to compare the length of LM to the length of its corresponding side. So Whitley, what side corresponds with LM? DC. And what is the length of LM? No, what's the length of LM? Remember, these little things in here with the degrees are your angle measurements. So what's the length of that side? And what's the length of DC? And now can I reduce that? I can reduce it by 14, so this becomes 1 over 1. Now, why is knowing that that ratio is 1 over 1 a good thing? Because that tells me they are the same, which tells me those are equal, which leads me to think that they are congruent. Because remember, if you're similar, okay, those are not going to be the same, because one might be a larger triangle than the other one. Okay? Number 8, what is the ratio of the side SL length to the length of its corresponding side? So if I do SL, what's the corresponding side to SL? No. What other side? What, FD? And what's the number measurement for SL? 13. And FD? And if I reduce? 1 over 1. Number 9, what is the ratio of MS to its corresponding side? MS corresponds to CF, and what's the measurement of MS and CF? So when I reduce, I get 1 over 1. Number 10, it's not showing up on my paper up here. It says, does each angle and its corresponding angle have the same measurement? Yes, it does. And for it to be congruent, it has to have the same measurement. Okay? All right. What angle corresponds to C? N. What angle corresponds to V? What angle corresponds to X? What side corresponds to CV? What? N. M. I was making sure we had that right. Which one? Do what? No, you need to have NM. Even though it's the same line segment, I need to make sure that N is matching up with C. Okay? All right, VX, XC. What's the ratio? 9 over 9, and I reduce to 1 over 1. 8, what's the ratio? Reduces. And X over XC. And do all the angles? Yes. And this tells me that my angles are congruent. Okay? Y'all did do a lot of work today. All right.